Hello everyone. Now consider the next example. We have to expand cos raised to 7 now. In earlier example we have studied how to expand sin raised to power, that is sin raised to 5. Now I consider second example, cos raised to 7. For cos, consider x is equal to cos theta plus I sin theta. 1 upon x is equal to cos theta minus I sin theta. Now adding this, for sin we subtract these two. Okay, for cos we have to add these two. What we get, x plus 1 upon x becomes 2 cos theta. Sin terms gets cancelled. Now consider raised to power 7 on both sides. What we get, 2 cos theta raised to 7 is equal to x plus 1 upon x raised to 7. Now expand this bracket using Pascal triangle. A is x, b is 1 upon x. A plus b raised to 7. Expand this by using Pascal triangle. Now next step, cancel the higher power of x in the numerator and denominator. We get this. Okay. Now combine first and last term, x raised to 7 and 1 upon x raised to 7 here. X raised to 5, 1 upon x raised to 5. Take common the numbers. 7 plus x cube, 1 upon x cube. Take 21 common. And last term, 35 common, x plus 1 upon x. And this is, we know, 2 cos 7 theta. This is 2 cos 5 theta. This is 2 cos 3 theta. This is 2 cos theta by using our theory. This is 2 raised to 7, cos raised to 7, LHS side. Now everywhere 2 is there, therefore cancel. Here in sin, everywhere 2i is there. We cancel 2i in the case of sin. While in the case of cos, we get 2 common everywhere, therefore cancel. Throughout 2 we get, divide by 2, we get 2 raised to 6 and cos raised to 7, and everywhere 2 gets cancelled, and this term as it is. Now cos raised to 7 becomes 1 upon 2 raised to 6 is 64 on that side, becomes comes in the denominator, and rest of the terms as it is. In this way we can expand cos raised to 7. And earlier we studied cos raised to sin raised to, how to expand sin raised to power. Okay, now this is the homework, you try it at home. That is, prove that cos raised to 6 minus sin raised to 6 is equal to this term. Expand cos raised to 6 like this, and sin raised to 6 again by using earlier example, and subtract these two, you get this term. Okay, now consider this. If sin raised to 4 theta into cos cube theta is given, this a1 cos theta plus a3 cos 3 theta plus a5 cos 5 theta plus a7 cos 7 theta. This is the given thing. a1, a3, a5, a7, these are just numbers. Okay, what we have to prove, a1 plus 9 a3 plus 25 a5 plus 49 a7 is equal to 0. This number comes to 0, we have to find out a1, a3, a5, a7 from the given thing. Okay, what is the given thing? This is the highest power of sin raised to 4 and cos cube. By using earlier theory, we have to expand sin raised to 4 and cos cube. Not we don't need to expand separately sin raised to 4 and cos cube. We have just one shortcut here. Let us consider x is equal to cos theta plus I sin theta. 1 upon x is nothing but cos theta minus I sin theta as usual. Now add these two, x plus 1 by x becomes 2 cos theta, and subtract these two, we get x minus 1 by x becomes 2i sin theta. These terms for sin and these terms for this we are going to use for cos. Cos power is 3, therefore take cube on both sides of this equation, and sin power is 4, therefore take fourth power on both sides of this equation, and multiply these two equations after taking indices. What we get, 2i sin raised to this 4 into 2 cos theta cube becomes this raised to 4 into this raised to cube. We are taking multiply both sides. Okay, now what is this? These are two brackets, a plus b into a minus b. Now what we have to do, observe the lowest number between these two numbers. 3 is the lowest number, and we have to split the highest number into this lowest number into other number. Right, here 3 is the lowest, therefore we have to split 4 into 3 into 1. If 2 is there, we have to split 4 2 into 2 like this. Okay, now this 4 raised to 4 indice of this bracket converted into 3 into 1, x minus 1 by x raised to 3 into this one. This term as it is, take it take a multiplication with this 2. Now what this step becomes now? A minus b into a plus b raised to these 3 take common and multiply this bracket and this bracket as it is. Now this bracket is a plus b into a minus b, that is a square minus b square. Okay, raised to cube as it is and this term as it is. Now expand this cube using a minus b bracket cube formula, where a is x square and b is 1 upon x square. Expand as it is and this term as it is. Now cancel in this bracket, cancel highest term, you get simply these terms into this bracket. Now throughout multiply these two brackets as it is. Okay, now remove this bracket by minus sign, take minus sign inside, we get this term. Again by earlier example, take highest power, same powers in the numerator and denominator terms together. X raised to 7 plus 1 upon x raised to 7 together. Again x cube and this is 1 upon x cube together, minus 3 take outside. Again 1 upon x raised to 5 and x raised to 5 take minus outside, we get this. And 1 upon x, this x take a 3 outside, we get this. Okay, again what is this? Again 2 cos 7 theta, this is 2 cos 3 theta, this is 2 cos theta, this is 2 cos 5 theta using earlier theory. If minus sign is there, it becomes 2i sine 5 theta and so on. Okay, now again expand this 2 on LHS side. What we get? This 2 raised to 4, I raised to 4, sine raised to 4, 2 cube cos cube theta is equal to rest of the term as it is. Now what is I raised to 4? I square, that is minus 1 plus 1, it gets cancelled. Again 2 cube and 2 raised to 4 add together, we get 2 raised to 7, sine raised to 4 and cos cube, this term as it is. Okay, now sine raised to 4 and cos cube, we have to find out this by given in the example, we have to find out sine cube and cos raised to sine raised to 4 into cos cube. Therefore take 2 raised to 7 on this side, we get sine raised to 4 into cos cube is equal to 1 upon 2 raised to 7 into this whole bracket. Okay, now multiply 2 raised to 6. Now again here 2 term gets cancelled, we get 2 raised to 6 here, and take on the next RHS side 2 raised to 6 on denominator everywhere, and 1 2 gets cancelled everywhere, that's why we get 2 raised to 6 here. Now we get by our theory this answer, and what is we have given? Sine raised to 4 into cos cube is this. Therefore comparing this with this equation, comparing we get, comparing here we say 1 and 2, they'll say this is supposed to, this is original equation 1. We get a7 value is nothing but 1 upon 2 raised to 6. Here a7 is nothing but cos 7 theta's coefficient. Therefore here cos 7 theta's coefficient is 1 upon 2 raised to 6. Therefore a7 is nothing but 1 upon 2 raised to 6. Likewise a3 is nothing but with sign minus 3 upon 2 raised to 6. a1 is 3 upon 2 raised to 6 and a5 is nothing but minus 1 upon 2 raised to 6. Okay, now we have to find out this. A1, consider this a1 plus 9a3 plus 25a5 plus 49a7. Here we get answer is 0. So all terms gets cancelled. Okay. Okay, now consider, you have to do this homework. If sine 6 theta is equal to this a cos raised to 5 theta sin theta plus b cos cube sin cube plus c cos theta sin raised to 5 theta, find ABC. Like earlier example, solve this, we get ABC values are, answer is this, a is equal to 6, b is equal to minus 20, c is 6. Again these are the homeworks. Expand sin raised to 8, expand cos raised to 8. Again this is again a tutorial. expand sine raised to 7 into cos cube. Like earlier example, you have to expand like this. Here hints are given. Okay. Now consider important point of this chapter. Roots of the complex numbers. Okay, consider the notes. 1 is equal to cos 0 plus I sin 0. We know sin 0 is 0, cos 0 is 1. Therefore, in some example, we need this identities, that is 1 is equal to cos 0 plus I sin 0. Minus 1 is equal to cos pi plus I sin pi. As sin pi we know sin 180 degrees 0, cos pi is minus 1. I is equal to cos pi by 2 plus I sin pi by 2, where cos pi by 2 is 0, sin pi by 2 is 1. Answer is I is equal to I. And minus I just replace plus by minus sign here. Okay, these 4 identity we have to use in these examples. Okay, now this also, cos theta plus I sin theta raised to 1 by n. 1 by n is nothing but nth root of this. Okay, for example, if x square is there, then what we call x raised to 1 by 2, it is a square root of x, right? If x cube is there, then what we call it is 1 by 3, its cube root, it is a root. And how much it is, which root is there? It is a cube root, it is a square root. Like it is x raised to 4, this is the indice, and 1 upon reverse term, the reverse number becomes root. And which root is there? Fourth root. Likewise, 1 upon n is nothing but nth root of this term, complex number. This is a complex number. And for that, if you want to use De Moivre's theorem, De Moivre's theorem is nothing but 1 upon n take inside to this angle, multiply to this angle. If whole integer is there, we can use De Moivre's theorem as it is. But when nth root is there, when 1 upon some number, that is root is there, we can't directly multiply this 1 by n to the angle. Before that, one step we have to do, that is add theta plus 2k pi. What is this? Add theta plus 2k pi to the angle. Okay, then 1 upon raised to n. These are two equal because we know cos of, this is one identity, that cos of 2k pi plus theta is nothing but cos theta. This is one identity. Also for sine, this is also same. 2k pi plus theta is equal to sine theta. Okay, we use this identity here. Therefore, replace theta by 2k pi plus theta here, and also same angle for sine. Now take 1 upon n inside. Therefore, for nth root, we have to remember one step, that before taking 1 by n inside to the angle or multiply to the angle, we have to add 2k pi to the angle. And where k values are, if n is there, k start from 0. N root, we have to find out n root. Therefore, if k start from 0, then last number will be n minus 1. Obviously, total number should be, count is n root are there. Therefore, k start from 0, 1, 2 up to one number less than this number. Okay, these two things we have to use in the examples. Now consider first example. Find cube root of unity. Unity means 1. Number 1 is nothing but unity or unit number. We have to find out cube root. 1 raised to 1 by 3. We have to find out 3 roots of this 1 number. Okay, let x is the cube root. What we have to find? Root, cube root. Therefore, let x is the cube root of unity. There, that is x is nothing but cube root, that is 1 raised to 1 by 3. We have to find out 1 x. That's why what we have to do, use 1 from this node, that is cos 0 plus I sin 0 here. Therefore, 1 instead of 1 we write cos 0 plus I sin 0. That is nothing but the polar form. Okay, this 1's polar form is this, raised to 1 by 3 as it is. Now we use this node. Before taking 1 by 3 inside, we have to convert this into we have to change angle 0 to 2k pi. Just add 2k pi angle to this 0 or this angle. We get cos 2k plus 2k pi plus 0, that is 2k pi only, plus I sine same angle 2k pi, rest to 1 by 3. Now take 1 by 3 inside. What do we get? Cos 2k pi upon 3 plus I sine 2k pi upon 3. Okay, and k starts from 0, 1, less than 1. There is less than 1 number from this number 2. Total number should be 3. 0, 1, 2. Okay, now what we have to find? Cube root of unity. 3 roots we have to find. Therefore put values of k, first 0, then 1, then 2. We get the x values. First root is, put k is equal to 0. Here what we get? x1, that is first root. In all the examples we have to use this nomenclature as first root will be x1, second root will be x2, and so on, while putting the values of k. Okay, now put k is equal to 0 here. We get first root x1 is equal to cos 0 plus I sin 0, which is again a 1. Okay, put k is equal to 1, next value. In this equation we get second root x2 is equal to 2 is 2 into 1, that is 2 pi by 3 plus I sin 2 pi by 3. Again by using calculator we can calculate cos 2 pi by 3. Cos in calci you have to write 2 into 180 divided by 3, because it is in degree. Okay, in calculator here it pi is a radian. Okay, we have to convert to calculate in the calci from radian to degree first. Okay, now this is exceptional step. You can do it or you can skip it. x2 is this second root. Now third root, it put k is equal to last value 2 here. We 2 to the 4 pi by 3 plus I sine value and sine angle and cos value must be same. This is this thing. Okay, these are the 3 roots. It's a very easy point to find out the roots. Now consider second example. If omega or w is cube root of unity like above, then we have to prove that 1 minus omega bracket raised to 6 is equal to minus 27, and 1 plus omega square is equal to 0. This we have to prove. Okay, now consider this. Let omega is the cube root of unity. It is given in the example, that is omega is the cube root. Therefore we have to take as it is. Therefore omega is a 1 raised to 1 by 3. Therefore omega cube, take cube on both sides. We get omega cube is equal to 1. Now take minus 1 on this side. Omega cube minus 1 is equal to 0. That's why we have to use a cube minus b cube formula here. What is a? Omega. What is b? 1. By this formula we get split into this. Omega minus 1 is into omega square plus omega plus 1 is equal to 0. Therefore omega square plus omega plus 1 is equal to 0. Now consider 1 minus omega raised to 6. This we have to prove minus 27. Therefore it is equal to 1 minus omega, this split this 6 into 3 into 2. Okay, this is one adjustment. Okay, this 2 into 3. Again expand this formula like a minus b bracket square, we get this. Okay, now again 1 minus 2 omega plus omega square. Here we have from this 1 plus omega square is equal to 0. Therefore 1 plus omega square value is, omega comes on right hand side as a minus omega. Put this value of 1 plus omega square into 1 plus omega square here, that is minus omega, and minus 2 omega as it is. Add this 2, we get minus 3 omega raised to cube as it is. Again 3 cube is 27, omega cube is minus 1 as it is. And again omega cube value is again 1 from this. Therefore answer is minus 27. Okay, and second we have already proved here. Okay, now consider next. Find cube root of unity and hence prove that they form equilateral triangle in the Aragon diagram. Okay, what we have to prove? We have to find out first cube root of unity. This question already we have solved in example number 1. This we have to solve as it is. Okay, now here we have just consider the answer because we have already solved it earlier. Okay, what we have to prove? They form equilateral triangle. What is equilateral triangle? Two sides must be same length and a third side can be different. Okay, this is the equilateral triangle. In Aragon diagram means if we plot these 3 points on graph, we already know what is Aragon diagram of a complex number. Okay, just plotting of a point. Then I am joining those 3 points, and what is the triangle made by that 3 point? We have to show that it is a equilateral triangle. Okay, now consider the answer as solved earlier, because this question we already solved. Roots are 1 comma minus half plus root 3 by 2i comma minus half minus root 3 by 2i. These are the 3 roots already we have studied in example number 1, solved in this example as it is. Okay, that is, these are 3 complex numbers, right? 1 is nothing but 1 plus 0i. It is a complex number. Again, this is again complex number, this is again complex number. Now we have to plot this complex number in Aragon diagram. What is Aragon diagram means? We have to plot this value as x, this value as y. That is order pair 1 0. This is minus half root 3 by 2. This is minus half minus root 3 by 2. These are the 3 points we have to plot on a Aragon diagram. Now consider this diagram. Suppose this is x axis, this is y axis, and we have to take 1 0 point. Suppose this is 1 0 point, it is on x axis obviously. Okay, this is suppose 1 0, and second one is minus half comma root 3 by 2. Okay, suppose minus half is again comes on x axis on opposite side. Suppose this is minus half. Okay, this is minus half, and plus root 3 by 2 in on y axis come in this quadrant. Obviously this is positive, that's why suppose this is a point root 3 by 2. Okay, and suppose, and now this is the point minus half plus root 3 by 2, and minus half, this is a minus half, and minus root 3 by 2 is a point again in the lower y axis, negative y axis, and same distance because point is same but opposite in direction. Therefore here is the point minus half minus root 3 by 2. Now what we have to prove? Let's join these 3 points. This is A point, B point, C point. Join these 3 points. What we get? This is obviously a equilateral triangle. Okay, joined by scale, you get this equilateral triangle because this distance is same obviously with this distance, and this distance is different. That's why it is a equilateral triangle. Okay. Now consider this example. If omega is 7th root of unity, that is, it is omega is given 7th root of 1, then prove that. What do we have to prove? S is equal to, this is a sum, 1 plus omega raised to n plus omega raised to 2n plus omega raised to 3n plus omega raised to 4n plus omega raised to 6n. Value of sum is 7 we have to prove, where n is a multiple of 7 is given, and it is equal to 0 otherwise. Otherwise means if it is multiple of 7, the value of sum is 7 we have to prove, and if it is not multiple of 7, the value of sum is equal to 0, that we have to prove. This is the question. Okay, let x is the 7th root of unity. Suppose x is the 7th root of unity, therefore x is equal to 1 raised to 7, 1 raised to 1 upon 7, 7th root. Again 1 replaced by cos 0 plus I sin 0 raised to 1 by 7 as it is. Again add 2k pi to this angle as earlier, we get this raised to 1 by 7, and cos 2k pi, take now 1 by De Moivre's theorem, 1 by 7 inside, we get cos 2k pi upon 7 plus I sin 2k pi, where k start from, here 7 is there, we have to take 7 values of k including 0, that is 1 0 1 2 up to 1 number less than 7, that is 6. Okay, now we have to put go on putting the values of k from 0 to 6 to get 7 root of unity. We have to find out those 7 root of unity. Therefore, putting values of k, we get 7 roots as, put k is equal to 0, we get x1 is like this. Put k is equal to 1, we get x2 is this. Suppose this is omega. Okay. Suppose put k is equal to 2, we get x3 is this. What is x3 and x2? What is the relationship between x2 and x3? We get again use the De Moivre's theorem here. 4 pi by 7, and from this angle we take 2 on indice using De Moivre's theorem, and this comes out to the same as x2 unit that we are already a term as omega. That's why it is omega square. x3 becomes omega square. Put k is equal to 3 here, we get 3 to the 6 pi by 7 here. Again take 3 on indice by using De Moivre's theorem. Only 2 pi by 7 we have to put it inside, and again this is omega, that's why x4 becomes omega cube. Like for example, we have to solve all these things. We get last root x square 7, seventh root, that is cos 12 pi by 7. Again take 6 on indice, cos 2 pi by 7 is, this is omega raised to 6. These are the 7 roots we have find already. Now what we have to take, we have to show that the sum is 7. First, if you take we have to take n is multiple of 7. Suppose let s is equal to